Today, in the video number 8, we shall study about electric field lines. It is also part of electrostatics and we are going to study about electric field lines. We already know that electric field is equal to force acting per unit test charge. We said the electric field E is equal to F upon Q naught. It's being a vector quantity, so electric field and force are both vector quantities. Now, Q naught is the positive unit test charge. Let us take for example an isolated positive charge. And this is a positive test charge. Positive being repulsed, the force is acting outward. So, I take an imaginary line and draw an arrow mark outward. Let us go to the negative isolated charge. Negative isolated point charge. And here it being negative, again test charge being always positive, it is getting attracted. So the line is going to be, the arrow is going to be inward. Now let us be clear. What are these electric field lines? These electric field lines are imaginary lines. Where do you draw? Suppose if I have an electric field here, right, and I draw an electric field line like this, okay, now why do you draw like this? It's a pictorial representation, it makes the visualization more clear. For example, when you take for example the solar system sun, and we have earth is there, the planets are revolving around. Now I cannot visualize it clearly, so what I do, I create an imaginary orbit. This is the path, but actually there is no path as such. It's an imaginary representation so that we can visualize it much better and easily. Similarly, when I talk about the electric field line, I'll find that, okay, this is the electric field line. Let us say it is passing like this, fine. And here somewhere electric field is there. Now what is the direction of the electric field? I take any point and draw a tangent at this point, and that gives me the direction of the electric field. The tangent drawn at this point gives the direction of the electric field. Now let me take for example there is a point here. Let me draw another tangent and the electric field direction is this, right? So the electric field lines are drawn in the electric field which gives the direction of the electric field at a particular point. Okay, now let us talk about the isolated positive charge. In the case of an isolated positive charge, I am drawing it like this, which is going to be outward, and I take a negative charge, opposite charge, and again I am drawing it like this, fine. And positive is, we have taken it outward, and for negative, we have taken inward. So, when I bring two isolated charges together, I bring it like this and I can complete it like this. Starts from positive, ends in negative. There are n number of lines, infinite number of lines. As you wish, you can draw. It's arbitrary, it's your choice. So, let me take one more line. Starts from positive, ends in negative. Starts in positive, ends in negative. Starts in positive, ends in negative. And so on and so forth. I can go on drawing it, right? And at a particular point, the line will vary a little bit differently, fine, okay? So I can take like this, I don't know how far it is going to go, I can leave like this, right? And it's like this, like this, like this, and like this, and like this, let us say. See, there are so many n number of lines are being drawn, but here it is going outward, and it is for the negative charge, it is coming inward. Fine. So this is about for a positive and negative charge. Electric field lines are there. At any point, it gives you the electric field. You know it's a tangent drawn at the point. So it's very simple. Now, if I take a positive charge and I take another positive charge, both of them being a similar charge, like charges, so they repel. So how will the electric field line modify you'll find that it is going to get repelled. That's the repulsive force. So there cannot be any attraction. There's a repulsion here. So there's no lines over here. So you will find that the lines are, again it is outward, 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 outward. Again here outward. Yeah. So the field lines, again it's imaginary line, and in between there is no electric field here because they both are repulsive. So the electric field lines do not appear there. There is no electric field. This idea of electric field lines was created by Michael Faraday. Michael Faraday introduced this concept for better visualization and pictorial representation to give you about the electric field. Fine. Now, let us learn about some of the properties of electric field lines. It's very important to know electric field lines and its properties. Let us look at it. First, we all know that it starts from positive and it ends in negative. Isolated charge. Starts in positive, ends in negative. Next, it is continuous curve and there is no break. There cannot be any break in between like this, which means there is no electric field here. No, it is not possible. So, it is all continuous curves. They do not intersect with each other. Watch carefully. Suppose if I take an electric field line like this, and suppose I say another field line starts from here and comes like this. Yes, they are intersecting with each other, which is not permitted. Two electric field lines can never ever intersect with each other. If they intersect, what does it mean? It means that, let us draw the tangent at this point. And let us draw the tangent at this point. Let us say T1 and you call this as T2. Two tangents are there. Now, how is it possible to have two tangents at a particular point? So, two directions are not possible, and so two electric lines of forces cannot intersect with each other. And one more point we have to remember is, as you come closer to the charge, the electric field lines will be more intense. The lines will be more and more, electric field lines will be closer. Okay, they will be more closer. It means the intensity of the field in this particular point, where closer, is very, 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 very high. So today we have learned now about electric field lines. This is the imaginary line drawn in the electric field. It's a pictorial representation. Gives the direction of the electric field at a particular point. And also we learned about the properties. It starts from positive, ends in negative. There is continuous curves and no breaks. Don't intersect with each other because two different directions are not possible, and does not have closed loop. In between it cannot form a loop like this. This is not possible according to conservative law. And the field intensity is high near the charges because 1 upon r squared. So as you go farther, the field intensity will decrease. You can have my WhatsApp number 8171198866 and you can send me message. I will send you handwritten notes in PDF which will be free of cost. Thank you.